Well, we're still dealing with bad weather outside, so I've got a project that I want to take to work today and work on, and it's with the Mystic 29. We're going to take this to my work today, and we're going to take the prop shaft out because this is a 150 cable, and we're going to a 187 cable. So I got this cable from Offshore Electrics. I think it was like 19 bucks, but it's huge. It's like literally the length of the boat. So we're going to take this to work today, and we're basically going to use the stock flex shaft as a template, and we're going to cut this down. We're going to cut our threads, do everything that we need to do in order to get this flex shaft to fit in this boat properly. Alright, so I'm here at work and I've got both of these drive cables. Now, this here was specifically made for the V1, V2, BlackJack 32, the Miss Geico 29, and the BlackJack 29. The shaft here was made about a ½ inch to a ¼ inch shorter than the stock shaft. So what it does, it prevents it from breaking. Because it basically, what would happen if you tried to trim any angle in it, it was trimming it, was putting the angle in right here, and it was snapping it off. So what they did was make the shaft shorter, so the shaft stuck out further to where the bend in the shaft was more here. So because this is a larger 3/16 cable, if you look at it, it doesn't start bending until about right here. So even though if we mark that there, the shaft doesn't start until right there, so we're going to lose about 3/4 of an inch. So my thought process, if I put them together like that, where both of these shafts start, because they ride on that lead bushing inside of the drive, this may cause a similar issue if I try to trim it up. Now the fix for that would be take this and move it forward like so. But now we're running out of shaft distance here, so we would essentially have to have more shafts sticking out the end of the strut with, you know, the prop sticking further out. And the further it sticks out, the more unbalanced it is, the harder it is on that bushing and on the whole entire drive assembly. So the closer you can keep your prop to the bushing or to the bearing, the better off you'll be to keep it running true. So what I'm going to do for starters is I'm going to take these and basically make them both even, and if I need to shorten it in the future, what I'll do is I basically will cut this the same distance, and if I need to shorten this end because I don't get any distance out of that, what I do is I can basically, I'm backwards there. I need to prep it like that, cut it here, and then once I go home, I can put it in the boat to see what it looks like. So basically, I'm going to cut my cable and leave it about 3/4 of an inch longer. And then when I get home, if my theory is correct, I don't have to do anything. But if my theory is incorrect, all I have to do is just trim off 3/4 of an inch of this side, which I will already have this soldered up. But I'm going to go ahead now, match these up, figure out where I'm going to cut it. I'm going to give myself more thread on this shaft, because depending on what prop that I run, I end up either having to run a spacer or I don't have enough area for the nut left. So we have about a little bit more, maybe 5/8 of thread here. I'm going to give myself about 3/4 of an inch of thread and go from there. So I got to go ahead now, pull out my die set and pull out my Dremel set, cut this thing off, and then we need to actually probably what I'll do is, since I already have threads here, I'm going to run a die over this down to that point, and then I'll just cut it off. Alright, so I've got my tapping die set here. We're going to use this. This is our thread indicator. So one side of this should be metric and one side of this should be standard. And basically I need both hands. So basically if you look at a thread indicator, you have all these teeth, and these teeth are going to match up to the threads on whatever shaft you're working on. So if you buy a tap and die kit, these are very, very important tools. So basically, you look at that, it says 32. So you see how those teeth line up? They line up beautifully. So we're going to look for a die that has 32. Alright, so we have a, what does this say? 10/32. That's going to be a die, and it says start this side. So basically, start this side means that goes in like so. But we need to put this in our die tool. And the most important thing here, in my opinion, is how do you hold on to this piece? Now, logic may say you just put it in the vise. But you need to be careful because this shaft needs to stay smooth and true. So my suggestion is get 2 pieces of wood, put it in your vise, and then clamp this in between it to where the teeth on this don't mar up the shaft. There may be a smarter way of doing this, but I don't have any other way of grabbing a hold to this without just using a simple vise and a piece of wood. Alright, so this is how I ended up doing it. I basically took this, and you can still kind of move this up a little bit, but it pinched about 50% of the metal shaft here. We're just gonna put a little bit of pressure on it, and these are just old pieces of pallet 2x4, and then I've got the die in here, got it started on the original thread. And what I did, so this is initially where I'm gonna cut it with my Dremel tool, and I want to thread it all the way back to this point here. So that's what I'm gonna do. I'm gonna go ahead now and continue on. So basically, when you do this, you do like half a revolution and then back 1, forward a revolution, back 1, forward half a turn, back 1, forward again, back 1, and you just continue on. You go nice and slow, and once you get up to the point to where there are no threads, you're going to start adding some sort of lubrication to it to help it cut, because this is, I believe this is stainless steel, so it's going to take quite a bit of effort to get it on there. So you're on a back and forth, back and forth, back and forth quite a bit to get that other 1.25 inches of thread that we need. Now, because this is stainless steel, you have to be very, very slow with it. So far I've been working it for about 5 minutes. I'll get about a half a revolution, and I'll take it off. I'll blow the threads out, get all the metal shavings out of it, then I'll start again. And start again. Realistically, the die itself is probably a little too small for the size of the shaft, so I'm using the die to cut all of the excess metal away, which is probably a little, about one, size over. They might have used a CNC like lathe to cut the end of the threads on this thing, or a machine die, I don't really know. But so far, in about 5 minutes, I've only gotten about 5/8 to 3/4 of an inch of new threads. But I'm taking my time and moving really slow and methodically. Like, I'm getting close to that piece there. I'm gonna have to get a new bite. See, if we use this as a reference, they both had equal thread length. That is how much I've added so far, and basically I got to get to about right here. So I got about 50% of the way more to go from what I've already added onto it. But we're working slowly, methodically, and the nut fits on it, so we're good to go. We just got to keep going, nice and slow. No need to rush. All right, so I ended up turning my vise sideways, and that is our final result, and that was what we started with. So we got that, and we can go down to there, and I've still got about a nut's worth below it. So I wanted to tap it that extra distance, but I'm gonna wait for right now. If I need to run the die over it a little bit more, I will. But basically I'm gonna cut 50% of these threads off now. It's easier to run the die across it with threads already existing than cut them off and then do that. So alright, time to cut that off. Alright, so I've got it all cut off, and I made sure I put a little machinist nut over top of it. That way when I go back through and take it off, it'll clean any burr off where I cut it. But I think we're good to go. Next thing, we have to cut this the right length, but I'm going to go ahead and take it home, and I'm going to measure it with the boat to make sure I do that correctly. Alright, I made it home, and this is the old cable versus the new cable. So we're looking at a 150 cable versus a what is that, a 187. So that's a 3/16 cable. If we line up both of the threads, we come down here and we see where I marked it. It basically ends exactly where I thought it would. But what I'm gonna do, I'm gonna cut it about a 1/4 inch long. And the reason why is because of this right here. I want this shaft to basically end a little bit closer. Let's see. I want it to end a little bit closer to right there in the center of the screen. If we zoom out and we go like so, that shaft ends about right here. But the issue with that is underneath the bottom of the boat, that shaft would end somewhere in the middle of that blue. I want it to end kind of closer to where the blue meets the aluminum right there. So even if I cut it just a 1/4 inch long, I can always just trim it later. So that's what I'm going to do now. I'm going to go ahead and use my Dremel with cutoff wheel and clamp this and go ahead and cut it. Alright, well, I just took my Dremel with the cutoff wheel and I went ahead and I cut it, and you can see where my mark was versus where I cut it. I just added maybe 3/16 of an inch of length. That way I can cut it off later if need be. I also, let's see if I can get it to focus, I also rounded it off nice and neatly. So now what I'm going to do, I'm going to get some solder, and we're going to create like a little thimble, like a melting pot and a smelting pot. And I think I know what I'm going to use, and I'm going to show that to you. Alright, so we're going to use this. This is a 6.5 mil Castle connector that came with one of my motors. It's basically trash. So I'm going to clean this out, and I'm going to put it over here in my soldering jig to hold on to it. And I'm going to take my cable, and I'm going to dip it in denatured alcohol to clean it, to make sure no grease, no nothing is inside the cable. And then I'm going to wipe it off, heat it up nice and good. Put this in here. I'm going to fill this full of solder, and while I'm filling this full of melted solder, I'm also going to be using the heat from the flame to also heat up the cable. Then I'm going to dip the cable in flux, and then I'm going to take the cable and I'm going to stick it inside the melted solder, and then hopefully watch the solder disappear into the cable. I've watched Ironclad do this, seemed to work pretty good. So I'm going to go ahead and copy something that he did. I'm just going to use a smaller little vessel. I don't think I need so much, because right there, that's almost the perfect diameter for the cable. So should hold all of the solder I need to give me a nice hard end. Alright, well, there's my little burnt thimble, and there's the end of my shaft. Turned out pretty good. Very happy with it. Ended up using twice as much solder as I thought I would need. But other than that, you just hold the heat on it, hold the heat on it, and hold the heat on it. Stick it in there, hold the heat on it. I took the cable and twisted it. I left it in there for about 10 to 15 seconds. Moved it around, pulled it out, looked at it, put some heat on it, stuck it back in there, pulled it out, looked pretty good. Takes a while to get the heat saturated in the cable in order to pull the solder into it. Alright, well, got it all cleaned up. Look at that. That looks beautiful. Almost looks like a professional did it. All I had to do is put that little brush on there, clean it up. Came out nice and good. It's hard, so see, it'll bend, and it will not bend at the tip. That tip is firm and solid, which is great because we have this collet right here that has to go on the end of that. Just like so. Bam! Yes, I'm so excited. Now I've got an updated Driveline. I don't have to worry about losing $40 props anymore. I mean, when you snap a drive shaft, you lose your prop, you lose your nut, you lose your drive dog, you lose everything, and you got to replace the shaft. So you're talking $30 for a shaft, $30 for a prop, and $10 for a nut and a drive dog. So you lose $70 every time something dumb happens to the Driveline. So updating to a stiffer Driveline is a must. So let's go ahead and slip this thing in here and see what it looks like. All right, and please excuse the mess. Excuse the mess. It's a nightmare in here. I've been working on getting shelves. So I just got those shelves put up and those shelves put up. And in order to do so, I had to take everything out of its spot where it was, put it on the table, put up my shelves, and you know how it is. So basically we're gonna go in here. That's our strut. You're gonna slide our cable right in, and you know what I like about this? It's not super tight, so it'll accept grease and not wipe it off. So we're gonna go ahead, and so okay, so I felt it's hitting the collet up front. So we're gonna go up here. We're gonna look. We're gonna make sure that that is lined up perfectly. It moves a smidge to the left, but not bad because it goes right in. And I think right now I actually have that collet a little tight. So let's see. Oh, like a buttered bud, a buttered muffin. Beautiful, beautiful. So now since we have that, let's get a drive dog. Alright, so we got the drive dog on there. We haven't tightened it in the collet yet, so it still pulls out, but the drive dog doesn't move. Now we do have a little bit of a gap. We may need a little bit more of one, and we'll put a little spacer behind it, but it's roughly where I would think we would need it. So let's see. Okay, fits beautifully. Come over here, let's grab a cool little nut. Oh, now doesn't that look sick? Oh my god, that looks sick. Put some light on it. Man, that looks so dope. Very, very happy with that. Super happy with that. That is a 43 mil 1.9 pitch. And I've got a bunch of different sizes and pitches coming. All CNC props. But yeah, that was the idea. So the rear little strut piece here, so from here, this piece here, that is the new updated version from OSC. I have the old one here. So this is a two-piece. This was the one with the brass bushing on the inside, and this one has like a lead Teflon bushing. So they said that the brass will heat up and it starts to gald to the stainless steel shaft, and once it starts to gald to the shaft, it creates heat. Even if you have grease on it, you're running it in the water, it creates heat on that binding, and once it starts to heat, it starts to basically weld to itself, put stress on the cable, and it twists the cable off because it's trying to weld itself to the end. So they changed this design to where it's a different style of bushing. But this boat is a 2011 model. It's super old. They don't have any parts for this anymore. So I just feel blessed enough that some company somewhere still has some things for this thing. But everything else I'm having to make, you know, custom or make it fit or work one way or another. But so yeah, this is gonna be awesome. This is absolutely gonna be awesome. The front of the boat, if you watched my video on reinforcing the hull, this thing is built like brick shithouse now. You know, it's got this area reinforced, the nose cones reinforced, the bottom of the sponsons inside reinforced, the sidewall seam reinforced, the center deck here, that's reinforced, the motor mounts reinforced, the whole center section. Everything about the hull itself is rigid now, no more flexing. So the driveline is rigid. I've got super high pressure cooling on it, so we're good there. I ordered another water outlet, so that's somewhere. Don't know where it's at, but I got another water port. So the next thing I have to do after this video is take this port out, and I'm gonna put another one either over here or back here somewhere, to free up space for the batteries. And I wanted to show you real quick some of the batteries that I got for this thing and give them a quick test fit. So these are the SMCs, HCLHCs. So these are the high capacity packs, 120C. But what I like about these, they're thinner, they're skinnier, but they're longer. So with a catamaran, it's all about weight distribution and how easy can you get the battery into the battery tray. And the other batteries that I have, you had to like pry that up just a little. And I actually took a Dremel, if you can see that seam right there, I took a Dremel and went around this seam and tried to take that lip off. I took more of it off over here, which actually it improved it. But I did a lot of measuring, and this is literally the biggest battery I can fit in here that will fit easily, besides going with the 5,000 Traxxas batteries. But yeah, that fits awesome. And I can move it forward, get a little bit more forward weight distribution on it to where it stops bouncing so much. The battery leads, those are perfect. It's going to be perfect. It's going to be absolutely perfect. So, but yeah, they come out nice and easy. Anybody else who knows this, you have to take off the cooling line to get the battery in. So this one is interfering right now. So that's why I'm going to take it off. But I've only gave this one test run. I tested it with the old cable. In the next video, I'll test this with my current setup with these batteries. We'll get a mile an hour, and we'll get, you know, based on performance on the video and whatnot. But this motor is an absolute beast for how small it is. Yeah, I love it. I love this whole hobby. Everything about RC boats is just so cool to me. Gives me something to do when I get home off of work. Keeps me inside the house. I got a boat for my girlfriend's son, so, you know, keep it. You get a little teaching involved and hand-eye coordination, and it's just, you know, spending time is what it's all about. So, yeah, this is awesome. It's turning out great. Not bad for a $150 boat. Now I've got triple that invested in it. Oh, that is sick. That is sick. Cool. Well, I'm going to end the video here. Thank y'all for watching. Stay tuned for more. If you're not subscribed, smash that subscribe button. Peace.